In this video, we're going to talk about finding an inverse function. Let's look at our first example here. We have f of x equals 2x plus 3. Part A wants you to solve for x when y is equal to f of x. So we have y equals 2x plus 3. And how do you solve for x here? You need to subtract 3 both sides. And then divide both sides by 2. So you get x equals y minus 3 all over 2. We're done with part A. What about part B? Find the input when the output is negative 7. Here the input represents the x value. And the output represents the y value. So basically we have to find the x value when the y value is negative 7. So just plug in negative 7 for y. And what is your x? It's negative 5. That's your input. Let's take a look at these two functions here, f of x and g of x. I made a x and y table for both of them. Now notice, when x equals negative 2 for f of x, the y value is negative 1. And when x equals negative 1, the y value is 1, and so forth. So you get 0, 3, 1, 5, and 2, 7. What about for g of x? When x equals negative 1, y value is negative 2. And when x equals 1, y is negative 1, and so forth. Do you notice something interesting about these two tables? That's right. The x values of f of x became the y value of g of x. And the y value of f of x became the x values of g of x. When this happens, we call f of x and g of x are inverse functions of one another. So basically, the domain became the range of g of x, and the domain of g of x became the range of f of x. And let's graph these two and see what happens. So we have a graph of f of x, which is 2x plus 3, and g of x, which is quantity x minus 3 over 2. Now, let's see what happens. Now remember, these two are inverse functions. Let's see what happens when you graph y equals x. So when you have y equals x, the y equals x becomes the line of inflection of these two graphs. So what do I mean by that? Let's say this is a paper, and when you fold the paper along the y equals x, these two graphs will overlap. So basically, let's say you draw a perpendicular line. The distance from here to here will be same thing as distance from here to here if you draw a perpendicular line. Just know that y equals x becomes the reflection, line of reflection of these two inverse functions. Also, let's say you have a 0, 3 on f of x, and guess what? You should have a 3, 0 on g of x because their domain and range interchanged. Now, how do you find the inverse of f of x equals 3x minus 1? So let's say that g of x is the inverse of f of x. How do you find what g of x is? Well, remember the domain and range changed. So let's just first start with y equals 3x minus 1. And let's solve for x. So you add 1 to both sides and divide by 3 both sides. So you get x equals y plus 1 over 3. So what you need to do now is this becomes y, g of x, and instead of y you have to just put x. So that is the g of x, that is the inverse of f of x. You could also do it this way. You could change the x and y. So x equals 3y minus 1, and then just solve for y. So add 1 to both sides, you get x plus 1 equals 3y, and then divide both sides by 3, you get y equals quantity x plus 1 over 3. So the inverse of f of x becomes just g of x equals x plus 1 over 3. I prefer to do it this way. Just change the x and y and just solve for y value to find the inverse. Now let's graph both of them and see what happens. So we have f of x equals 3x minus 1 and g of x, quantity x plus 1 over 3. So y equals x becomes a reflection line of f of x and g of x. So let's choose a nice point here, negative 1, 0 for g of x. That means you need to have 0, negative 1 for f of x. And we do. The distance from here to here is the same thing as distance from here to here, because y equals x becomes a reflection line. In order for a function to have an inverse, it must pass horizontal line tests. So you guys know about the vertical line test, how the graph needs to pass vertical line test to be a function. And look at both of these two functions. They're functions because they both pass vertical line test. However, unlike this one, this graph over here does not pass horizontal line test because you have more than one interception. In order for function f to have an inverse, you got to pass both the vertical and horizontal line test. Let's find the inverse of f of x, that is equal to x squared. But look at the restriction of the domain. They say x has to be greater than equal to 0. Now, why do you think they gave us the restriction on domain? Let's take a look at the graph of x squared. You know that the graph looks like this. It's a parabola. Now, does that pass horizontal line test? It doesn't, because you have more than one intersections. But if think about the restriction, if we let x greater than or equal to 0, then we're only looking at this portion of the graph of x squared. Now this passes the horizontal line test. That's why we have to have a restriction on domain of x squared. Now how do you find the inverse of that? Well, you know that y is equal to x squared. In order to find the inverse, you have to change the x and y and solve for y. So what do you get? You get positive negative radical x equals y. So you have two equations here. You got y equals radical x or y equals negative radical x. Which one is it? Well, there are two ways of looking at this. First, how does the graph of y equals radical x look like? You know that it looks like this. This is y equals radical x. What about y equals negative radical x? Well, that looks like this. The x-axis becomes a reflection line. So this becomes y equals negative radical x. Now remember, two inverse functions, if there are two inverse functions, then y equals x becomes a reflection line. So which one is the reflection of y equals x squared? Is it y equals radical x or y equals negative radical x? It's y equals radical x. This is a reflection of y equals x squared with respect to y equals x. So you know that the answer is y equals radical x. Also, the other way of looking at it, look at the domain. Domain is positive, 0 and positive, right? The domain of f of x becomes the range of inverse function. So the range has to be positive, which means the y value has to be positive. This one, the y values are negative. So that's another way of looking at how to choose whether y equals radical x or y equals negative radical x is the inverse of x squared. Let's see if f of x equals 2x cubed plus 1 has the inverse function. If it does, let's find the inverse. So first, we need to graph this and see if it passes the horizontal line test. So here's a graph of 2x cubed plus 1. And it does pass the horizontal line test. So this function has inverse. So how do we find the inverse function of this? Well, again, let's say y equals 2x cubed plus 1. We're going to change the x and y value. X equals 2y cubed plus 1. And then we're going to solve for y. So let's subtract 1 both sides. And divide by 2 both sides. And we got to cube root both sides. And don't put positive and negative. You only do that when the exponent is even. This is going to be our inverse. So our inverse is going to be g of x equals cube root of x minus 1 over 2. And let's graph this and see what happens. So we have f of x, and we got the inverse we just found. And here's y equals x. Graphically, it supports our answer. Let's go ahead and find the inverse of f of x. First, why don't you graph it and see if it passes the horizontal line test. And you will notice that it does. So in order to find the inverse, let's write it as y equals 2 radical quantity x minus 3. So what we're going to do is we're going to interchange x and y. And we're going to solve for y. So in order to do that, we have to divide both sides by 2. And we need to square both sides. So you end up getting x squared over 4 equals y minus 3. And we need to get rid of negative 3, so add 3 to both sides. So our inverse, g of x, will be x squared over 4 plus 3. Just be careful that you need to have a restriction here because this is a parabola. So if you look at this graph, the range of this graph is 0 and positive. So that means the domain of this graph has to be also 0 and positive. So x has to be greater than or equal to 0. If f of x and g of x are inverse functions, then this will happen. F of g of x is equal to x, and g of f of x will equal to x. So if you want to show that two functions are inverse of one another, all you got to show that this is true. And I'll show you an example. So how do we show that these two are inverse of one another? Well, first, we need to show that f of g of x is equal to x. So what is f of g of x? Okay, so what is our g of x first? G of x is quantity x plus 1 over 3. So we're going to put f of quantity x plus 1 over 3. And what is f of quantity x plus 1 over 3? Well, so instead of this x, we need to plug in x plus 1 over 3. So it will be 3 times the quantity x plus 1 over 3 minus 1. And what is that? Well, 3 cancels out. You're going to get x plus 1 minus 1, which is just x. So we show that f of g of x is equal to x. Now our second part, we need to show g of f of x is equal to x. So what is our f of x? Our f of x now is 3x minus 1. So I'm going to put g of 3x minus 1. And show that will equal to x. So we have g of x. So instead of x, we got to put 3x minus 1 instead of x. So you end up getting g of 3x minus 1 is equal to 3x minus 1 plus 1 all over 3, which is negative 1 plus 1 cancels out. You get 3x over 3, and which is just x. So we also show that g of f of x is equal to x. Therefore, we proved or showed that these two are inverse functions.